Scientific discovery has always been this grand search, right? Whether it's finding life-saving drugs or creating world-changing materials, it's a quest for that one perfect solution in an ocean of possibilities. But what happens when that ocean is basically infinite, and finding the answer could take a lifetime? Well, what if we could build an AI to be our explorer?
We've all heard the old saying, finding a needle in a haystack. But in modern science, that haystack is, well, it's bigger than you can possibly imagine. And the needles we're looking for, they have the potential to literally change the world.
Scientists have a name for this haystack. They call it the search space. The best way to think about it is like a huge invisible landscape. Every single point on this landscape is a potential new drug, a new material, a new answer. The highest peak is the perfect solution. But the problem is, almost the entire landscape is completely uncharted.
And as the researchers behind this point out, finding that peak with just a handful of clues, that's the holy grail of science. So why is that? It's because every single data point, every little experiment or computer simulation can cost millions of dollars and take months or even years. You just can't test everything. You have to be incredibly smart about where you look.
The thing is, our traditional tools for navigating this landscape, they're like using old, incomplete maps. They just aren't good enough. Let's dig into why our old methods keep getting us lost.
And this slide really breaks it down. On one hand, you have traditional AI like Bayesian Optimization. It's great, but it's like having a map for a small town. It works fine there, but it gets completely lost in the sprawling complexity of anything over about 100 dimensions. On the other hand, you have the heavy hitters like reinforcement learning, the kind of AI behind AlphaGo. The problem is it's designed for a totally different game. It needs millions of data points and a clear score to work, which is something most scientific problems just don't have.
So if your old maps don't work, you need a brand new kind of explorer. One that's actually built for this specific, treacherous, and massive terrain. And that's where Dante comes in.
Now, Dante stands for Deep Active Optimization with Neural Surrogate Guided Tree Exploration. I know, it's a mouthful, but its mission is what's so critical, to dive into these enormous complex landscapes and find the best possible solution, and to do it efficiently, using an incredibly small amount of data.
So how does it pull this off? It's a really clever loop. First, Dante takes whatever data we already have and trains a neural network to draw a rough map of the landscape. Then, a smart tree search algorithm looks at that map and plans a route, picking out the most promising new spots to check. Next, we validate those spots with real experiments. And here's the magic. That brand new data gets fed right back into the network, making the map better and better with each cycle. It's a constant process of learning and discovery.
All right, so let's pop the hood on this thing. Let's look inside Dante's toolkit and really understand what makes it such a revolutionary guide.
At the very heart of it all is the cartographer, a deep neural network. You can think of this as the AI's brain. It takes all the known data points and creates a predictive map of the entire search space. It's not just connecting the dots we've found, it's learning the complex rules of this invisible world to predict what we'll find in places we haven't even looked yet.
But hey, a map is pretty useless if you don't have a pathfinder to read it. That's the Neural Tree Exploration, or NTE. This is the strategy engine. It looks at the map the neural network drew and makes the tough calls. Should we dig deeper in this area that already looks good? Or should we take a risk and venture out into the great unknown where an even bigger prize might be hiding? It's always trying to find that perfect balance.
And this pathfinder has some seriously smart rules. It uses a technique called local backpropagation to make sure it doesn't get stuck on a small hill when the real mountain peak, the best solution, is just over the ridge. It also has conditional selection, which is a fancy way of saying it doesn't waste time on paths that are clearly dead ends. And my favorite is adaptive exploration. When Dante finds a really promising region, it gets more adventurous and ramps up its search right there.
Okay, so the theory sounds incredible. But does this new explorer actually deliver out in the wild? Let's take a look at the proof.
2000. Just let that number sink in for a second. That's the number of dimensions Dante can handle. Remember how we said the old methods got lost after 100? This isn't just a step forward. It's a monumental leap that lets us tackle problems we used to think were flat out impossible.
And this chart says it all. These are standard, incredibly tough benchmark problems for AI. Look at the state-of-the-art methods. They just hit a wall. For the Rosenbrock function, they fail at just 10 dimensions. Dante solves it at 200. For rastrogen, they tap out at 100. Dante breezes through it at 2000. It's not just a little bit better, it's playing in a completely different league.
When you apply this to real-world problems, it translates into this massive performance boost. In head-to-head showdowns, using the exact same amount of data, Dante consistently found solutions that were 10 to 33% better than the next best thing. In science, an improvement that big isn't just an improvement, it's a breakthrough.
And we're not talking about theoretical wins here. The researchers have already used Dante to do some incredible things, designing new high-performance alloys, calculating the best flight paths for a lunar lander, and even optimizing microscope images better than a human expert. And this is where it gets really exciting. It's also being used to find new peptide binders, which is a key step in creating new medicines.
So, what does this all mean? Let's zoom out. What we're looking at here is more than just a really clever algorithm. We are looking at a fundamental shift in how science itself actually gets done. Because this technology makes something possible that sounds like science fiction. Self-driving laboratories. Seriously, just imagine a fully automated system where an AI like Dante not only designs the next experiment, but tells a robot to run it, analyzes the results, and learns from them. 24/7 without anyone needing to be there. The speed of discovery could just explode.
And don't just take my word for it. The researchers who created Dante believe this is the future. They predict that these kinds of tools are going to become standard practice, letting us finally solve problems that, up until now, we just considered completely impossible.
For centuries, we've been drawing maps of the world around us. Now, we have an AI that can chart the vast, invisible landscapes of scientific possibility. And that leaves us with one really exciting question. With AI explorers like Dante to guide our way, what on earth will we discover next?